Okay, so we understand what process capability is, as a concept. We'll have the garage and the car in all the videos from now until the end because it's very important to understand what we're looking at. Okay, so we're looking at the distribution from a sample that we collected data, and we're looking at the specification limits of the customer and trying to see if it fits exactly into the specifications. Because if it doesn't fit, I'm generating too many quality problems, right? I'm generating too many defects. Okay, so let's another way to imagine that is thinking about the distance between the mean and the lower specification limits. So we need to understand that to understand the two different things that we're going to calculate, which is the capability index and the capability ratio. Okay, so imagine that I have a nominal value, a mean in the middle, I have a lower and upper specification limits. Oops, sometimes I do that. So what's happening here is that what's happening here with the car. Yes, and hopefully you guys know exactly what I'm asking now. The car is too big. It means that the distribution is too high. Okay, so the distance between the mean and the lower specification limits is only 2 sigma. And what I want is to be at least 3 sigma level. Okay, so if the distance is 2, means 3 is probably here and it's too far away. All this will be quality defects that I'll generate in the lower and in the upper specification limits. What's going on here? Well, here the car is very small, right? It's like what we have in a Cinquecento, Fiat Cinquecento, or a little electric car or whatever. And it's very easy to park because it can fit more than one car. So the distance in this case between the mean of my distribution, okay, this distribution, and the lower is actually 4 sigma. Okay, means that I'm generating a very, very, very low number of defects from this side, and it's very, very easy to park my car, which has only 3 sigma, right? So my car actually finished here and here. So I have all this extra space, right? So one standard deviation each side of extra space to park my car. Okay, what's going on now? Well, now I'm trying to park, a bike into a garage, which is very, very easy, right? So I have a lot of space. So the amount of quality problems that it'll generate, it's very low, right? Ridiculously low. So my process will be capable of producing at 6 sigma level, okay, which is very unlikely that some problem happening. And that's great because I'm generating less cost, like internal cost and external cost, right? So we talk about that. It's kind of the goal of improving quality of the process is to make it produce less defects. So I have less quality cost of internal and external. Okay. And then just to understand, the difference is we're going to take a look at the process at 3 sigma level, and it could be 6 or 4 or 2. And what that means is that, it's the size of the car comparing to the space that I have available. My car will always be a 3 sigma level to the right and to the left. But in this case, it's generating defects outside the limits, right? So I couldn't park. It's not capable of producing at 3 sigma level.